What's up, Chanel?
Hey, Sharice.
What you doing?
I'm working on this project for my teacher, Mr. Winters, about the golden ratio.
Ooh, I heard he's annoying.
No comment, no comment.
So, like, basically, what are you doing? Like a video project?
Yeah. I think I'm going to do a video or a poster board or something like that. And I have to put 4 real life examples about it in it.
Really? Who you working with?
Me, Namaya, and Kevin.
Really?
Yeah.
I know a little information about it. So
you do?
Yeah, girl. So, if you need help, I can come help you out.
Okay. Well, so far, I know that the golden ratio is also known as the golden section or divine proportion. And this is when the division of a line segment in such a way that the ratio of a whole segment to the larger part is equal to the ratio of the larger part to the smaller part. And the ratio is approximately 1.61803 to 1.
So basically, it's like saying 9 out of 10 or 1 out of 3, stuff like that.
The ratio. Yeah.
Oh, okay.
Yeah.
I may have some stuff out art and architect and stuff like that. So, just let me know.
Okay, so I found some more information for our project.
Hey, I got some examples for us too. The golden triangle, the golden rectangle, and the formula.
When a hawk approaches its prey, its sharpest view is at an angle to the direction of flight, an angle that's the same as a spiral's pitch. The Fibonacci sequence can also be seen in the way tree branches form or split. A main trunk will grow until it produces a branch, which creates 2 growth points.
Even our bodies exhibit proportions that are consistent with Fibonacci numbers. For example, the measurement from the navel to the floor and the top of the head to the navel is the golden ratio. Animal bodies exhibit similar tendencies, including dolphins. The eye, fins, and tail all fall at golden sections. Starfish, sand dollars, sea urchins, ants, and honeybees. The number of petals in a flower consistently follows the Fibonacci sequence. Famous examples include the lily, which has 3 petals, buttercups, which have 5, the chicories, 21, the daisies, 34, and so on. Phi appears in petals on account of the ideal packaging arrangement as selected by Darwinian processes. Each petal is placed at 0.618034 per turn out of a 360-degree circle, allowing for the best possible exposure to sunlight and other factors.
Hey guys, that's good.
Yeah.
That's good. That's enough.
Hey y'all, what's up?
Oh, you want to sit down? Oh, thanks, man.
So, I have some information or whatever about the golden ratio, and I want you guys to have it. So here you go. Everything is on there.
You got all the information. You might as well be in the group.
Are you asking?
Yes. Can you please join us, please?
You ain't even have to ask,
Hey.
This picture includes lots of golden rectangles. In a above figure, we can draw a rectangle whose base extends from the woman's right wrist to her left elbow and extend the rectangle vertically until it reaches the very top of her head. Then we will have a golden rectangle. If we draw squares inside this golden rectangle, we will discover that the edge of these new squares comes to all the important focal points of the woman: her chin, her eye, her nose, and the upturned corner of her mysterious mouth. It is believed that Leonardo, as a mathematician, tried to incorporate mathematics into art. This painting seems to be made purposely to line up with the golden rectangle. We can notice that this picture is positioned to the principal figures in alignment with a pentagram or golden star. This picture is a well-known example in which you can find a golden triangle and also pentagram. In this picture, a golden triangle can be used to locate one of its underlying pentagrams. This picture is painted inside a golden rectangle. We can find part of an enormous dodecahedron above the table. Since the polyhedron consists of 12 regular pentagons, it is constantly connected to the golden section.
This is the Parthenon. The Greek sculptor Phidias sculpted many things, including the bands of sculpture that run above the columns of the Parthenon. A rectangle whose sides are in the golden proportion has been known since it occurs naturally in some of the proportions of the 5 Platonic. This rectangle is supposed to appear in many of the proportions of that famous ancient Greek temple in the Acropolis in Athens, Greece. This is the Great Pyramid. The Anmes Papyrus of Egypt gives an account of the building of the Great Pyramid of Giza in 4700 BC with proportions according to a sacred ratio. This is the Notre Dame in Paris, which was built in between 1163 and 1250, appears to have golden ratio proportions in a number of its key proportions of design. Although it is rather asymmetrical in its design and difficult to measure photographically because of parallel distortions, the golden ratio lines of the green, blue, and red rectangles conform closely to the major architectural lines. The CN Tower in Toronto is the tallest tower and freestanding structure in the world, and it has the golden ratio in its design. The ratio of the observation deck at 342 meters to the total height of 553.33 meters is 0.618, or 5, the reciprocal of 5.
The head forms a golden rectangle with the eyes at its midpoint. The mouth and nose are each placed at golden section of the distance between the eyes and the bottom of the chin. The beauty unfolds as you look further. Even when viewed from the side, the human head illustrates the divine proportion. The first golden section, blue, from the front of the head defines the position of the ear opening. The successive golden sections define the neck, yellow, the back of the eye, green, and the front of the eye and back of the nose and mouth, magenta. The dimensions of the face from top to bottom also exhibit the divine proportion in the positions of the eyebrow, blue, nose, yellow, and mouth, green and magenta. This photo illustrates the following golden ratio proportions in the human face. Center of pupil is to bottom of teeth is to bottom of chin. Outer and inner edge of eye is to center of nose. Outer edges of lip is to upper ridges of lips. Width of center tooth is to width of second tooth. Width of eye is to width of iris. In this photo, note the following golden ratio proportions that appear throughout the human face. The blue line defines a perfect square of the pupils and outside corners of the mouth. The golden section of these four blue lines defines the nose, the tip of the nose, the inside of the nostrils, the two rises of the upper lip, and the inner points of the ear. The blue line also defines the distance from the upper lip to the bottom of the chin. The yellow line, a golden section of the blue line, defines the width of the nose, the distance between the eyes and eyebrows, and the distance from the pupils to the tip of the nose. The green line, a golden section of the yellow line, defines the width of the eye, the distance at the pupil from the eyelash to the eyebrow, and the distance between the nostrils. The magenta line, a golden section of the green line, defines the distance from the upper lip to the bottom of the nose and several dimensions of the eye.
This video demonstrates what we learned about the golden ratio.
And Mr. Winters, we just want to let you know that you are so
Eddie!
But we did learn a lot.
And we thank you for teaching us such wonderful things and giving us this wonderful project. And cheers to you, Mr. Winters. Hey!
I like you,